Hello everyone, good morning. Can you able to hear me and is my screen visible to everyone? It's put it in the chat box. Okay, fine. So how was your exam? Was it like easy paper or a moderate one or it was a hard one? Okay, so in today's class, we are going to discuss the answers and analyze the paper, okay? Okay, so we'll start the class without any delay. Fine. So, like going with the section one. So, section one was it has 8 questions and it is of a numerical type answer question. All the questions are compulsory, and here, like you have a negative mark of -1 and full mark of +2. Okay, and if you don't attend, you won't get any marks. So, like moving to the first question in numerical section. So, the first question is the mass of glucose that would be dissolved in 50 gram of water in order to produce the same lowering of vapor pressure. Okay, so same lowering of vapor pressure as is produced by dissolving 1 gram of urea in the same quantity of water is the question. Okay, so you have to calculate the mass of glucose in gram that would be dissolved in 50 gram of water in order to produce same lowering pressure as it produced by dissolving 1 gram of urea in the same quantity of water. So quantity of water is going to remain same. Okay, so it is like 50 gram, 50 gram. The quantity of water is going to be like 50 gram, 50 gram of water on. Okay, so here it is 50 grams. So because they have given us like same quantity of water, so for both the solutes, it is going to be like 50 gram. So you have to calculate 1 gram of urea is given. 1 gram of urea is given. The unknown is like you have to calculate the mass of glucose in gram. You have to calculate the mass of glucose in gram. Okay. So here like what approach you'll be doing, like what formula you'll be using, and tell me like from which chapter this question is from. Yes. So here what you have to do is like two things, three things you know. Okay. So that is the mass of water you know for both, and you know the mass of one solute, that is for urea, you have to calculate the mass of the other solute, mass of glucose you want to calculate. Okay. And they have told you that the lowering of vapor pressure is going to be same. Lowering of vapor pressure is going to be same. It means that I'm going to equate the vapor pressure. Okay, I'm going to equate the vapor pressure. So, like anyone have answered this question? Have you got the answer? If anyone have done with the question, you can put the answer in the chat box. Okay, so what I'm going to do is I'm going to equate the pressure of glucose is equal to the change in lowering of vapor pressure of urea. Okay, so I'm going to equate the glucose and urea lowering of vapor pressure. Okay, so now we know that the lowering of vapor pressure is equal to the mole fraction. Yes, it is equal to the, I can write of glucose is equal to the mole fraction of urea. Mole fraction of urea. Okay, so now like what is mole fraction? Mole fraction is number of moles of solute by total number of moles. Yes, so mole fraction is number of moles of solute by total number of moles in glucose, and number of moles of solute by total number of moles of urea. Yes. So now number of moles of glucose. So what is like glucose? You have to calculate the mass. Okay, it means that the number of moles is unknown, and we know that number of moles formula is Mass by molar mass. Mass by molar mass. Yes, mass by molar mass. So I can write this one as like WB, yes, by NB is the molar mass of glucose into, for the solute I can write as MA by WA is equal to WB by MB into MA into WA. So I have got like one answer from SR. Okay, we'll check the answer as well. So now what I'm going to do is like substitute the values. So this is what you're going to calculate. Okay, so I'm keeping it as it is. And MD. MD is what? It is the molar mass of the glucose, right? So what is the molar mass of glucose?
180.
It is 180 into mass of A. What is A? A is your solvent, which is water. So mass of water is given here. It is like 50 gram. And what is the molar mass of water? Ma. Molar mass of water is
18.
18. Okay, molar mass of water is 18. So 18 by 50 is equal to WB is the mass of urea. Mass of urea is given as 1 gram by molar mass of urea. So what is the molar mass of urea? What is the formula of urea? Is NH2,
60.
CO2. So this is urea. So if you calculate the molar mass, it is going to be like 60 into, again, MA by WA is 18 by 50 because they have given you, you're going to use the same quantity of water. So it is going to be like 18 by 50. Okay. So now just do the simplification. Like this part is going to be cancelled. So it will be like 3. Okay. So WB is equal to 3. The answer is going to be, okay. So the mass of glucose would be dissolved to get the same lowering of vapor pressure by dissolving 1 gram of urea in 50 gram of water is going to be like 3. So if you dissolve 3 gram of glucose in 50 gram of water, you'll get the same lowering vapor pressure by dissolving 1 gram of urea in 50 gram of water. Okay, got this question, everyone? Are you clear
Yes.
with this question? Shall I move to the next question? Okay, fine. So moving to the next question, you have to find the total number of unpaired electrons in T2 orbital of central atom in COF6 3-. Okay. So do anyone have attended this question and what answer have you got? You have to find out the total number of unpaired electron in T2G orbital of central atom in COF6 3-. So here the coordination number is going to be like 6. Coordination number is going to be 6. Okay. So it is, what type of complex it is? It is an octahedral complex. So for octahedral complex, how would be the splitting? Like which will be in the lower energy and which will be in the higher energy? For an octahedral complex, when you take like T2G and EG, which will be in the lower
Outer
energy, which
complexes.
will be in the very good. So T2G in the lower energy, EG in the higher energy, right? So you'll be having, for it first you have to calculate the oxidation state of COF6 3-. Can you tell me the oxidation state of cobalt and oxidation
Cu plus
state
3.
of cobalt? Very good. Cobalt and COF6 3- is going to be, like we know that for fluorine it is going to be like -1. So -6 is equal to -3, X is equal to plus. So you have to write the cobalt configuration. Cobalt configuration is argon 4s2 3d 7. Here plus 3. So for plus 3 oxidation state, you have to remove 3 electrons. So if you remove 3 electrons, what will be the configuration? Argon remove 3 electrons. So 2 electrons will go here, -1. So 3d. Okay. So now you have like 6 electrons. And now the octahedral splitting takes place. You have to find out the total number of unpaired electrons in T2G orbital. Yes. So now do the splitting. So I have like 6 electrons and it is split into Eg and P2G, P2G, Eg. Okay. Now for filling the electrons in this T2G and Eg, you must know like whether the ligand is a strong field ligand or a weak field ligand. So tell me like fluorine is strong field ligand or a weak field ligand? Fluorine is strong field ligand or a weak field ligand?
Weak field
Yes,
ligand.
it is a weak field ligand. It is a weak field ligand. So the electrons after filling T2G and T20, you have to pair it. Okay, pairing takes place. All orbitals are completely full. All the orbitals are completely filled. So I am going to fill the electrons like 6 electrons. 1, 2, 3. I have filled T2G. I have to fill EG. Only then I have to pair. But if it is a strong field, I completely fill the T2G and then move to the EG. Okay. So now what is the question? It is T2G for EG. Total number of unpaired electrons in T2G. So how many unpaired electrons are there in T2G? How many unpaired electrons are
Electrons.
there? Okay. So therefore the answer is going to be like 2. So everyone got this question? Shall I move to the next
Yes.
question? Any doubt with this question? Okay. So moving to the next question. So here a compound is given. You have to find out like which nitrogen in the above compound is most basic. They have numbered the nitrogen. So this is like your first nitrogen, and this is like your second nitrogen, and this is your third nitrogen. You have to find out which nitrogen in the above compound is going to be like most basic. Any answers like 1, 2, or 3? Nitrogen is going to be more basic. Very good. I got like Ankita given the answer as 2. Is it is going to be the right answer. So it is because you can see this nitrogen will have a lone pair. We know that for nitrogen, you can have like 3 bonding electron and 1 lone pair electron. Yes. So therefore you have like 1 lone pair over here. Here too you have lone pair. Here too you have lone pair. Now, what is meant by like basic compounds are the one which act as an electron donor, Okay, so therefore it should contain a lone pair which is like it should be present on the nitrogen atom itself. So I can say that it should contain a localized lone pair. Okay, so when I take like this nitrogen, here you can see that there is like some sort of conjugation. Okay, so you can see that you have a conjugation. What type of conjugation you have? What type of conjugation you have? Look over the conjugation. You have a pi bond. You have a sigma bond. Yes. So when you look over here, you have a pi bond, you have a sigma bond, and you have a lone pair. Okay. So we know that the types of conjugation like pi bond, sigma bond, lone pair is there, and there will be like delocalization. So what may happen is like this bond can move over here and this lone pair can move over here. Like, or else like this lone pair can move always from lone pair it will be moving. So this lone pair can move over here and pi bond can move over here. So now this lone pair is localized or a delocalized one? It is a delocalized. It is delocalized lone pair. Delocalized lone pair. Now when I move to second one, here there is like any type of conjugation. Can you see like any pi bonds surrounding the nitrogen atom? No. So this one will not involve in the resonance. So therefore no conjugation. It is going to be like localized. It will stay on nitrogen atom. But here what happens? It is moving. It is moving. Okay. And now moving to this one. Here you have a pi bond. Here you have a sigma bond. And again you have a lone pair. So will it undergo resonance? The lone pair present on the third nitrogen atom, will it undergo resonance? Yes, it will undergo. So because there is like conjugation, you have a conjugation over here, so it will undergo. So this is also a delocalized lone pair. It is also a delocalized lone pair. So in the second one, the lone pair on the nitrogen atom will not move. There is no delocalization. So it will stay on the nitrogen as it is. Hence, it is going to be like more base. Okay. So clear with this question, everyone?
Yes, ma'am.
Clear? Yes, ma'am. So therefore, the answer is going to be like, so the answer is 2. So moving to the next question. Consider the following statements. Okay. N2O3 is an acid anhydride of HNO2. HCl is oxidized into Cl2 in presence of CuCl2. I2O5 is used in the estimation of CO. What is the number of correct statements among the given statements? Like you have to check all the statement is correct or incorrect and count the number of correct statements. Okay. So moving to the first statement. Can anyone give the answer for this question? Like read all the 3 statements and count the number of correct statements. Okay, I got like 1. Okay, so we'll analyze it. N2O3 is an acid anhydride of HNO2. So we know that like what is acid anhydride? Anhydride is, what is anhydride? The compound, okay, the resultant, what you obtain by removing water. Okay, so removal of water. Hydrate is water and it represents to removal. So removal of water. Okay, it is acid HNO2. HNO2. And when I take like one more molecule, and here the removal of water takes place between 2 molecules. Okay, removal of water between 2 molecules. So again, I'm writing like HNO2. Yes. Now what you have to do is like remove one water molecule. So hydrogen will move out, one hydrogen will move out, and one oxygen will move out. So minus water will give you have like how many nitrogen? 1, 2 nitrogen. So N2, how many oxygen you have? 2, and one oxygen has been moved out. So therefore you have like 1. So totally N2O3. So can I tell that N2O3 is an acid anhydride of HNO2? Yes, it is.
Yes.
Okay, while you remove like one molecule of water between 2 molecules of the same compound, it is known as anhydrate. And here, like, I'm removing one molecule of water, it got N2O3, so therefore it is an acid hydrogen. Now, HCl is oxidized into Cl2 in presence of CuCl2. So when HCl is oxidized in presence of CuCl2, will it give Cl2? It means that 2HCl should react with CuCl2 to form CO2. That it means that HCl is oxidized into Cl2. We know that like removal of hydrogen is oxidation. Yes, removal of hydrogen is oxidation. So here what happens, like it forms Cl. So is it true or false? Is it true or false? Or tell me like from where this equation have been come? What is the method? Can you like get the method? Can you get the method? Like have you studied this preparation of chlorine? Preparation of chlorine. Have you like learned this Decon's process? Decon process. Okay, so in Decon process, we'll be manufacturing chlorine in presence of CuCl2. Okay, so what happens over here is like direct oxidation of hydrogen chloride takes place. Okay, so here this CuCl2 is CuCl2, it will, when you heat this one, it will thermally decompose to Cu2Cl2. Cu2 and Cl2. It will thermally decompose into Cl2. And it reacts with the Cu2Cl2 is of oxygen. It will give you product in which this Cl2, it will give you products over here. And in presence of HCl, when you put the presence, like when you add HCl, it will produce. Okay, so this is how the Cl2 is manufactured using the Decon's process. So here this statement is also true. And moving to the third one, I2O5 is the estimation of CO. I2O5. Okay, I2O5 is used in the estimation of CO. For estimating carbon monoxide, I2O5 is used. So all the three are right. All the three are okay. So the answer is going to be like. So moving to the next question. The rate constant for the decomposition of a certain substance is 1.7 into 10 power minus 2 decimeter cube mole inverse second inverse and 2 into 10 power minus 2 decimeter cube mole inverse second inverse at 37 degrees Celsius. if order of reaction is X and Arrhenius parameter is given of the reaction is Y decimeter cube mole inverse second inverse, then Y into 1000 by 43 X is going to be, and they have given you the calculating value too. Okay, so they have given you the ln value, R and E power value also they have given. Okay, so what is given in the question is they have given you the rate constant for the decomposition of certain substance is 1.7 into 10 power minus 2 and 2 into 10 power minus 2 at 37 degree Celsius. If order of reaction is X and the Arrhenius parameter is Y, you have to calculate this Y. So what is Y? Y is you have to calculate the Arrhenius parameter, you have to calculate the order and then substitute over here to get the answer. Okay. So now moving with order. Okay. So by seeing the unit itself, you can tell the order of the reaction. So the unit is like decimeter cube mole inverse and inverse. So what would be the order of the reaction? Decimeter cube is liter. Yes, 1 decimeter cube is like 1 liter. So if the unit is
Second order reaction.
liter, mole inverse, second inverse, then this is going to be what? This is going to be for the second order reaction. What is the unit for first order reaction?
Second inverse.
Yes, for first order reaction, it is going to be second inverse. And what is the order for zero order reaction?
Mole second inverse, liter inverse.
Liter, here it is like liter, right? So just inverse, liter inverse, mole second inverse will be for the zero order reaction. Now by seeing the unit itself, you can just tell X. So what is going to be X? X is your order, so second order. So X value is going to be like, okay, now you got X. What is the next thing you have to evaluate is the Y, okay, which is the Arrhenius parameter. So first you have to write down the Arrhenius equation. What is like Arrhenius equation?
K equal A e raised to power minus E upon RT.
Yes. So I can write like you have to do the Arrhenius equation, right? So Arrhenius parameter. So I'll rearrange the equation as A is equal to K into E power EA by RT. Okay. So now you have to calculate this A, which is nothing but your 1. Okay, which is nothing but your 1. So now, first I will evaluate this part E power EA by RT. EA by RT, which is equal to E power. And what is EA is the activation energy. EA is the activation energy. So you have to do the activation energy. You have to do the activation energy first. Okay. So how will you calculate EA, activation energy? What is the formula to calculate the activation energy? What is the formula to calculate the activation energy? So using this temperature terms, okay, you can calculate, right? So ln K1 by K2 is equal to EA by R into 1 by T2 minus 1 by T1. So using this, right, you have like two rate constants given. So using these two rate constants, you can evaluate EA. Okay, so now just substitute and evaluate EA. So ln of, I am taking like this as K1 and this as like K2. Okay. So now K1 is like 2 into 10 power minus 2 by K2 is 1.7 into 10 power minus Okay, so 2 into 10 power minus 2 by 1.7 into 10 power minus 2 is equal to EA by R. Here they have given you to put like 8.3. So I'm putting the same value, 8.3 by D. So here the temperature is missing. The constant of a certain substance is given. One temperature is given, the other temperature is missing. So it should be like actually one is like at 310 degrees Celsius. So when I add this 273 to 37, I'll be getting 310. And this should be at 300 Kelvin. It should be at 300 Kelvin. Okay, so here this data is missing in the question. So 1 by T2 minus 1 by T1. So therefore, here when you minus this one, right? So T1 is 310, T2 is 300. So it will be like 10 by 300 into 310. So just evaluate 10 power minus 2 will get cancelled. And then ln 2 by 1.7 is equal to EA by 8.3 into 10 by 300 into 310. Okay, so if we evaluate this one, you'll be getting EA as 12504.78 joule per minute. So now I got like EA. I got EA. Just substitute over this. So 12504.78 by RT. By RT. So R value is like 8.3. And the maximum temperature is at 310 degrees Celsius. So, sorry, 310 Kelvin. So, I'm making it as like 310. 310. Okay. So, now if we evaluate this part, okay. So, E power 4.86 will be getting, which is equal to 129. It is given here itself. So, making it as like 129. No need to do this. You can do the calculation over here because the value is given here itself. Okay, so just write the value as it is. So now we got like E power EA by RT. Yes. So Y is equal to K into the rate constant. Okay, so here we have taken like 310, which is your temperature T1. So for taking K1, you have to take K1. So this one. K is 2 into 10 power minus 2 into 120. 120. Okay. So A value will be equal to like, so that is Y value will be equal to 18,245. So it will be 2.58. So now you got like Y, you got X, just substitute over here. So Y into 1000, 2.58 into 1000 by 43 into X value is 2. So 43 into 2. You get the answer. So just evaluate this, you get the answer. So it will be like 30. So yeah, answer is going to be 30 is your answer. Okay, so got this question, everyone?
Yes, ma'am.
Okay. So moving to the next question. How many of the transformations given below would result in aromatic amine? How many of the following transformation would result in aromatic amine? What would be your answer?
First, third, fourth.
First give.
First, okay, first one is right.
Third and fourth.
Third one is right. Yes, very good. Okay, 1, 3, and 4. Yes. So can you tell me the name of the first reaction?
Hoffman
You have in
bromamide.
mind? Very good. Hoffman bromamide degradation. So in Hoffman bromamide degradation, when bromide in presence of Br2 and NaOH, one of the carbon, you have to write the resultant such that degradation happens. It means that one carbon is going to be like this. So you have a benzene phenyl ring and you have CO. Okay, so I am cutting out this CO completely and I'm writing the product as NH. Now I got the aromatic amine, so I'll get aniline as the product. Now, what is the name of this reaction? Second one.
Gabriel-citrullamide.
Very good. It is Gabriel phthalimide synthesis. So in Gabriel phthalimide synthesis, what type of amine you'll get?
Primary amine.
Primary.
Aliphatic.
Primary. Yes. Aliphatic amine. So it will not produce the aromatic amine. Okay. So it will not produce. Now moving to this. This is a simple reduction. So when NO2 is reduced, you'll be getting NH2. And here, when you have like NHCOCH3, when you put dilute sulfuric acid and heat it, what happens over here is like a bond will be broken down over here to produce NH. Okay, so here the options are going to be like A, C, and D are going to be the right. Moving to the next question. So they have asked the counter. So therefore, the answer is going to be 3. Yes. A solution of pH 2.0 is more acidic than a solution of pH 6.0 by a factor of 10 power x. What would be the value of x? Yes. So what would be the answer? pH of pH 2.0 is more acidic than a solution of pH 6.0 by a factor of 10.x. Then what would be the value of x is the question. Okay. So here I'll just write the concentration of H plus. So pH is equal to 2. It means that what would be the concentration of H plus? 10 power minus is the concentration. Yes. If pH is equal to 6, what would be the concentration of H plus? Is 10 power minus 6. Now, what is the factor H plus? Factor is the difference is going to be like 4. So
20
by a
power 4.
factor of 10 power x. So the value is going to be like, okay. So the difference is 10 power minus 4. So the acidic character decreases by a factor of 4. So answer is 4. And the next question is on adding excess of AgNO3 solution into 0.01 mole compound PTBr Br4 dot X NH3 0.03 moles yellow precipitate was obtained. What would be the value of X? What would be the value of X? We'll write the equation first. Okay. So you're adding excess of AgNO3 to this complex. Okay. So PT Br4 dot X times of NH3 in presence of AgNO3. What will happen over here? Ag and Br will get precipitated as AgBr. Plus, you'll be getting a complex ion. You'll be getting a complex ion. Now, 0.03 moles yellow precipitate was obtained. Okay. So, initial number of moles is you are adding excess of AgNO3 solution into 0.01 mole of the complex compound. So, initial at time t is equal to 0, you'll be having 0.01 and this is X. and at time t is equal to t, you're getting like 0.03 moles. 0.03 moles of AgBr. Okay, so if it is like 0.01 produces 0.03 moles. So 1 mole will produce how many moles of AgBr? 0.01 produces 0.03. 1 mole will produce
3 more.
3 moles of AgBr. It means that 3 Br have been ionized. Okay, so you'll be getting like 3. If it is for 1 mole, you'll be getting 3 AgBr. So 3 Br have been ionized and 1 Br is remaining in the complex. Yes. So what would be the complex now? This complex ion. What you have got would be like Pt. Yes. So here you'll be having only 1 Br, 3 AgBr have been produced. Means that 3 Br have been ionized. So PtBr NH3, it is an octahedral complex, right? NH3 5. NH3 5. So 5 plus 1 is going to be like 6. So 3 Br have been moved out. So this is the whole complex. So now what would be the value of X here? X times of NH3. So what would be the value of X? So X would be equal
5.
to 5. X would be equal to 5. So 5 is the answer. Okay, got this question, everyone?
Yes, ma'am.
Moving to the next question. Okay, so it is like one or more than one correct option. So you'll be having like full marks and negative marks there. So moving to the question, which of the following molecules which has or have high electron density in ring B is compared to ring B? Okay, so you have like two rings A and B in all the questions. So which among the question in which ring B has the higher electron density than the ring A is the question.
A, C, and D.
Okay, A, C, and D. Very good.
D.
A, C, and D is the right answer. A, C, and D. Okay, so we'll check. So when I have like B and here A, this A is attached to C double bond O. So C double bond O, since this oxygen is highly electronegative, it will withdraw the electron towards itself. So whenever there is a carbonyl compound, due to the high electronegativity of oxygen, you will be having a partial positive charge on carbide. So therefore, I'll be having a positive partial. Okay, so now what happens? It will withdraw the electron, and also you can see that there is a sort of conjugation, so it will withdraw the electron. So electron density is decreased. Okay, and here you have like oxygen. So therefore, compared to B, like A's electron density is decreased. B is greater than B. Yes. So now moving to the second one. Here you have like NH and you have oxygen. Okay, so when I have like one lone pair, oxygen will be having two lone pairs. But when I compare the electron negativity of nitrogen is less than that of oxygen. So oxygen will like pull more electrons than nitrogen, and also I can say that NH2 is the more activating group compared to OH, right? If I break this and put hydrogen over here. So NH2 is like more activating, yes. So than the OH. So here A is going to be more electron denser than B. Now moving to this one. Now I have like AB, yes. So now this one is attached to a electron withdrawing group. Both are attached to electron withdrawing group. But B is having an electron releasing group, right? C2H5. So what I can ask over here is like plus sign. So plus I effect acts on ring B. So electron density will increase. So B is done. Now moving to D. Here it is a minus I group, or I can say it is electron withdrawing group. And B is attached to an alkyl group. It is attached to an alkyl group. Okay, so plus I effect will happen. So therefore, we can say that B is greater than A. So therefore, option A, C, and D are going to be the right answer. Yes, clear with this question?
Yes, ma'am.
Yes, ma'am.
Moving to the next question. In which of the following reactions Na2CrO4 will be formed as one of the products? Na2CrO4 will be formed as one of the products. Or you can tell like CrO4 minus. When you write in ionic form, where CrO4 to minus will be formed as the product. Will not be formed as one of the product is the question. See here, you have like Cr2O3 plus Na2CO3 in presence of oxygen. Okay, in presence of oxygen. And here you have like FeCr2O4 plus Na2CO3 plus oxygen is there. And here you have like Cr2O7 2 minus in alkaline medium. Okay, so Cr2O7 2 minus in alkaline medium will give you CrO4 2 minus on. Yes. Now here FeCr2O4 plus Na2CO3. So what happens over here is like this Fe will take up the carbonate and it will move as a carbonate. And here too like Cr2O3 plus Na2CO3 plus oxygen is there. Okay. So here you have Cr2O3 plus O2 in presence of H plus. So in acidic medium, what you will get like Cr2O3 in acidic medium will give you Cr3 plus. It will not produce CrO4 2 minus. But here it is a basic medium. Here too it is a basic medium. So in basic medium, you'll be getting CrO4 2 minus as the product. Okay, you'll be getting this as one of the products. So here I can say the sodium carbonate is a base. Here too sodium carbonate is a base. Here too you have a base. Like all the three has base in it. So therefore CrO4 2 minus will be formed as a product here. Because here it is an acidic medium. In acidic medium, Cr2O3 will produce Cr3 plus. It will not produce CrO4 2 minus. Option C is where the Cr3 plus will not be formed. Okay, so by seeing like picking out the odd one out, this question is like picking odd one out. Okay, just analyze that. Leave the thing which is given over here. Okay, look over. Like this is also a base. It is base. It is base and it is an acid. So all the bases will give like same type of where this is an oxidizing agent, right? So when an oxidizing agent is there, like oxidation takes place. So all the bases will give like same type of product, whereas CH plus will give you like Cr3 plus. So therefore option C is going to be the incorrect. Clear with this question? Moving to the next question. Given the standard electrode potential, okay, they have given the standard electrode potential of K plus K is minus 2.93 volt, Ag plus to Ag is 0.8, Zn2 plus to Zn is minus 0.76, Cr3 plus to Cr is minus 0.74. So all these are oxidation potential or reduction potential. All these are oxidation potential or reduction potential. Yeah, reduction potential. So they have given you the reduction potential, which would be the incorrect statement. Zn can reduce K plus Ag plus and Cr3 plus. Zn can reduce Ag plus Cr3 plus but not K plus. Zn can reduce K plus but not Ag plus and Cr3 plus. Zn can reduce K plus Cr3 plus but not Ag plus. Okay, so first you just arrange the elements in order of the reduction potential. Okay. So reduction potential of K plus is for potassium, it is like very minimum. So potassium, then comes, it is minus 2.93. Then comes like for zinc, it is minus 0.76. For chromium, it is minus 0.74. And for Ag, it is like 0.8. So this is your reduction potential order. Reduction potential order. Now, can you tell me like which among the options are true?
B.
Yes.
B is correct.
Zinc can okay, I have to write this as like Ag. Ag. Okay. So now zinc can reduce Cr K plus, Ag plus, and Cr3 plus. Is it true?
No, ma'am.
Is it true? No. So zinc, it will not reduce K plus, Ag plus, and Cr3 plus because see the position of zinc over here. Okay. So therefore, this is also an incorrect statement. And zinc can reduce Ag plus, Cr3 plus, but not K plus. Is it true?
True.
Yes, it is true. Yes. So zinc can reduce Ag plus and Cr3 plus, but it could not reduce the K plus. It is going to be true. And since they have asked you to choose the incorrect statement, okay, see the look the question, it is incorrect statement is going to be true, but and also it is not going to be your answer. Now zinc can reduce K plus, no, it can't reduce K plus. Yes, so the option C is incorrect. Zinc can reduce K plus, again it cannot reduce. Option D is also be the incorrect statement. So A, C, D are the incorrect statement and B is the correct. Okay, got this question?
Yes, ma'am.
Yes, ma'am.
Okay. Moving to the next question. During the denaturation of proteins, which of the structures will not remain intact? Which will not remain intact?
Intact means
Which will not degrade?
primary.
Which will not collapse? Primary will not collapse, right? Will not collapse. So here the question is like will not remain intact. Which will collapse? Intact means do not collapse, but the question is like will not remain intact. So which will not remain intact? Which will be collapsed is the question.
B, C, and D. Secondary, tertiary.
Very good.
and
B, C, and D. Yes. So what is like denaturation of proteins? When you denaturate, right, the quaternary structure, tertiary structure, and secondary structure will be broken down. Only the primary structure will remain. Okay. So the one which is broken down is asked over here. So B, C, D is the right answer. Moving to the next question.
Yes, ma'am.
1 mole of monoatomic ideal gas perform the following operation in which all the steps are reversible. The correct statement about the process A to B is the correct statement of the process A to B. Delta G is greater than 0, delta S is greater than 0, delta H is greater than 0, Q is greater than 0. Process A to B. A to B. So here you can see that the temperature is remaining constant over here. For the A to B process, the temperature is 3. So what type of process it is?
isothermal.
Very good. It is isothermal process. It is isothermal process. It is an isothermal process. The process of A to B is isothermal process. So for an isothermal process, what would be like change in enthalpy?
0.
0. Change in internal energy?
0.
0. For an isothermal process, change in enthalpy, change in internal energy will be equal to 0. And we know that according to first law of thermodynamics, delta U is equal to Q plus W. Yes. So therefore here delta is going to be like 0. So 0 is equal to Q plus W. So what will be Q? Q will be equal to minus W. So here work is going to be negative and Q is going to be like positive. So which among the statement is true? What would be like delta S and delta H? Delta S and delta G. So here from this we can understand that Q is greater than 0 is the right type. Yes, delta H greater than 0 is going to be like incorrect because delta H should be equal to 0. Now evaluating delta G and delta S. So for a spontaneous reaction, delta G should be positive or negative.
Positive.
For a spontaneous reaction, delta G should be
Positive. Delta S must be
positive.
positive.
Positive. For what is the criteria for spontaneity?
Reaction occurs
Delta G
automatically.
must be negative.
Delta G should be negative. Delta S should be
Positive.
positive. We know that delta G is equal to delta H minus T delta S. So if delta G should be negative, delta H we know that it is equal to 0. Yes. So if delta S is going to be like a positive value only, then minus into plus is going to be minus. So delta G will be negative. So delta S should be positive. So B is true. Delta G here greater than 0 is given, which is wrong. So the correct answers are B and D. Yes. For this question, everyone.
Yes, ma'am.
Okay. So moving to the next
Yes,
question.
ma'am.
Which of the following is our correct statement? So carrying method is used for the estimation of Geldar's method is used for the estimation of nitrogen. Carrier's tube is used in the estimation of sulfur and phosphoric acid produced on oxidation of phosphorus present in an organic compound is precipitated as Mg2P2O7 by adding magnesium mixture. So which of the following is our correct statement?
A is incorrect.
Yes, A is
A
incorrect.
is wrong.
So yes, A is wrong. Very good. So Carrier's method is used for the estimation of sulfur and halogen. Yes, sulfur and halogen. So this is going to be incorrect. Geldar's method is used for nitrogen. Carrier's method is used for the estimation of sulfur is right, and the statement is also right. So therefore B, C, and D are right statements. Next question is okay. So it is a matrix match type question. Okay, so in column A, column 2, the compounds are given, and in column A, the like number of pi bonds and structures are given. You have to match it. It is a matrix match type question. Like more than one match is also going to be true over here. You can apply like more than one match also. So first for it, what you have to do is like draw the structure of this for all the 1, 2, 3, 4, 5 given. Okay. And then you're going to match with these two. So first, just draw the structure of HCF6. HCF6 is going to be octahedral. Yes. So now here lone pair is given, pi bond is given. So is there like any lone pair
Yes,
on
one
Z
lone
bond?
pair.
Yes, ma'am.
Distorted.
1, 2, 3, 4, 5, 6. So therefore, how many lone pair you'll be having?
One lone pair.
One lone pair. You'll be having one lone pair. So the geometry is going to be
Distorted.
distorted octahedron. Yes. So distorted octahedron with one lone pair is given. So option C, you can match it with option C. And is there like any pi bonds? No pi bonds. So therefore, I can't match it with any one of the options. So option C is going to be for B. Now moving with like
C.
XCO3F2. XCO3F2. So where F must be present and where oxygen should be there, like whether in axial bond or equatorial bond. Fluorine. Fluorine should be in axial or equatorial portion.
D option for Q.
Yes. So therefore, how many pi bonds? You have like pi bonds, yes? So you have like 3 pi bonds and it is a trigonal pyramidal shape. So option D is going to be the right one. Now moving to like XCO4.
Option A.
XCO4. Yes. It has 4 pi bonds and no lone pair. So therefore it is going to be a tetrahedron. So option A. And Da to XCO6. So OBA. OBA. So 2 I have done over here. 1, 2, 3, 4, 1, 2, 7, 8. Da to XCO6. So removing by 1. Okay, so what is the correct match over here? 1, 2, 3, 4, 5, 6, 7. It's done with the operator. Now, what is the correct match?
B.
D.
It has like 2 pi bonds, and you have 6 over here, so it can form an octahedron. So S is going to be like B. And ClF6 minus. ClF6
No pi bond.
minus. ClF6. 5 and 6. ClF6 minus. It has like lone pair.
Yes.
One lone pair
Yes,
because
ma'am.
minus is given. Yes. So therefore it is going to be like distorted octahedron. So C. Okay. So ClF6 and XCF6 have one lone pair and distorted octahedron. So the correct matches, like you have to match it for A. A is going to be R. B is going to be S. And C is going to be like P and the T. D is going to be second. D is going to be Q, right? Q. So this is the correct answer. Okay, I've got this.
Yes, ma'am.
Okay. So moving to the next question. Match the column 1 with column 2. H2SO8, H2SO3, H2SO4, H2SO7.
CR.
You have to like name the compounds.
Peroxydisulfuric acid.
Yes, it is peroxodisulfuric acid. P is R. Okay, R. H2SO3 is
Sulfurous acid.
sulfurous acid. P. H2SO4 is
Sulfuric acid.
sulfuric acid. H2SO7 is
Pyrosulfuric acid.
pyrosulfuric acid. So this is going to be the next. Moving to the next question. Okay, so here with the column 1, you have to match it with the reagents given.
AR.
Hoffman degradation is Br to NaOH. Yes. Clemmensen reduction.
BS.
Yes, very good.
BS.
Cannizzaro reaction.
Concentrated KOH. P.
Concentrated pH. You can use like any base, any word for pH.
PQ.
Remer Kaiman is going to be like now tell me like what are the products you'll be getting during Hoffman degradation? This will
Amine.
revise it. Yes, you'll be getting
Amine.
amine. Yes. Clemmensen reduction.
Alkane.
Alkane.
Alkane. Very good. Alkane. Cannizzaro reaction.
Salt of carboxylic acid and alcohol.
Both oxidation as well as reduction taking alcohol and salt of acid. Remer Kaiman.
Aldehyde.
Benzaldehyde.
Aldehyde.
Salicylic.
Salicylic acid and salicylaldehyde.
Aldehyde. Okay, so these are the products we'll be getting from the thing. Okay. Yes, next one is match the column 1 with column 2 and choose the correct answer given below the table. N equal to 6 to N equal to 3 in hydrogen atom. How many spectral lines will be getting and what would be the spectral region? Okay, in which region you'll be getting? N equal to 7 to N equal to 3 or for hydrogen atom only. So you can use a formula. Can you tell me the formula for the possible spectral lines?
Delta N bracket delta N plus 1 divided by 2.
Delta N plus 1 by 2. So now moving with like N equal to 6 to N equal to 3. N equal to 6 to N equal to 3. So the change is going to be like 3 only. So 3 into 3 plus 1 by 2. So how many spectral lines will be
AR.
getting? I'll be
6.
getting like 6
6.
spectral lines. And in which region
ER.
the
R.
emission takes place? In which region does the emission takes place? It takes place in N equal to 6 to N equal to 3, right? So it takes place in infrared region, IR. So N equal to 1, N equal to 2, N equal to 3. So this is in UV visible IR. So N equal to 3 will be for IR. So next is, I can match this like R and S for A, R and S. N equal to 7 to N equal to 3.
10 lines.
4 into 4 plus 1 by 2 is equal to 10. So 10 lines. And
Infrared
what will be
region.
the region again? Just yes,
Infrared.
Infrared.
Yes. 5 to 2, the difference is 3.
6 lines.
6 lines. So R and where will be the region for 2?
Visible region.
Visible.
Visible region. So Q. And again 6 to 2 is 4. You'll be
10
getting
lines.
10.
10 lines.
Visible. So P and D. So this is the matrix match. Okay, so in matrix match, just be careful, like more than one can also write. Okay, so you have to write match it, see all and match. If there is like more than one match, it is also going to be right. Okay, so it should be careful like with matrix match right question. If it is a match, then no problem. Like column 1 will be apt only with one option in column 2, but in matrix match type, more than one can also be right. Even 3 or even all the 4 could also be right for the 1 in the column 1. Okay, so therefore be careful like while doing the matrix match. Okay, clear?
Yes, ma'am.
So first paper is over, I hope. Moving to the second paper now. I'll check the paper once. Yes, this is your second paper. Okay, so for the complex compound, what will be the total number of geometrical isomers? What would be the total number of geometrical isomers? What is the type here? It is M, A, B, C, D. Okay, so for M, A, B, C, D, what will be the total number of geometrical isomers?
Four.
It will be equal to 3. Okay,
3.
so for M, A, B, C, D, the total number of geometrical isomers is going to be 3. And next question is the number of electrons in sigma 2p bonding orbital of B2, C2, and O2 are X, Y, and Z respectively. What would be the value of X plus Y plus Z by 2s? Okay, total number of electrons in sigma 2p bonding orbital for B2, C2, and O2 are X and Y, Z respectively. What would be the value of X plus Y plus Z? Sigma 2p orbital. So for this, you have to draw the MO, right? You have to write the MO configuration. So totally, how many electrons in B2? It is going to be like 10 electrons. So the MO configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. We got like 2, 4, 6, 8. Then here the pairing will not take place. So it will undergo the sp mixing. So after sigma orbital, there will be like pi orbitals. Pi to px, pi to p1. Yes, so 1 and 1 will be getting. So is there like 2, 4, 6, 8, 10? Now it has been completed. So no electron in sigma 2p5. So X is going to be like 0. Now moving to C2, the number of electrons is going to be like 12. So what will happen over here? What will be the number of pi to px and pi to p by orbital electrons?
1.
1 or 2, 2. It is 12, right?
2, 2.
2, 2.
Only 2 electron in
Number of
case of
electrons would be
O2.
like, it is 8. Okay, totally it is 8 over here. For B2, it is like 1 and 1. 10 will become, so for C2, it should be like 2 and 2. So 8 plus 2, 10 plus 2, 12. Okay. So what will be like Y value over here? There is no sigma 2p is at 0. Sigma 2p is equal to 0. And when I move to O2, for O2, what will be the configuration? Here it is going to remain same. It is going to remain same. What about the sigma 2p is that? Now the total number of electrons is going to be 16.
16.
It is going to be 16. So here it will be like sigma 2p is it? Then comes pi to px, pi to p1. Here, no sp mixing. After 14 electrons, there will be no sp mixing. So 2, then comes 14, 16. Thirteen, 14, and then comes the pi orbitals. So this is the total configuration of O2. Now we have to like do it for sigma 2p Z only. So for sigma 2p Z, how many bonding orbitals? You have like 2 electrons. So Z value is going to be 2. So X plus Y plus Z by 2 is going to be like
2 by 2,
So
1.
the answer is going to be 1. Yes, very good. And the next question is, the total number of stereoisomers are possible for the given compound X, then the value of X by 8s. What is the total number of stereoisomers? So the total number of stereoisomers, geometrical by optical, is given by 2 power n. Okay, so n stands for the number of chiral or stereoisomeric centers. So like how many, what would be n value over here? 1, 2, you have like 2 chiral centers over here. Yes. So here you have like 3. So this one is going to be like hydrogen, hydrogen. You won't get over here. But here it is like 1, 2, 3, 4. Okay, so 4. And then it is going to be 5 and 6. Okay, so 1, 2, 3, 4, 5 and 6. So n value is going to be 6. So 2 power 6 is equal to 64 x by 8. So value of x is 64. So x by 8 is going to be 64 by 8 is going to be like 8. So the value is going to be 8. Yes. Got this question? Okay, so here you have to check
Yes,
like
ma'am.
both optical as well as stereo symmetrical isomers. So here you have like 2 double bonds and 4 chiral centers. So totally it is going to be like 6. And evaluate, you'll get 8 as the answer. Next question is, okay, so consider the statements given below. You have to evaluate the statements first and find the sum of number of correct statements. So if like suppose 1 and 2 are correct, then answer should be 1 plus 2 equal to 3. So this is the question.
First statement is wrong and
Okay. Solution showing negative deviation from Rawls law or only entropy driving. Yes, it is like false, incorrect. Osmotic pressure of a solution is an intensive property. Is it an intensive property? It involves like temperature, right? Pi is equal to CRT, concentration, temperature. So it is an intensive property. And as you have same composition in liquid as well as vapor phase, which is through showing positive deviation from Rawls law or entropy driven is true. Yes, it is entropy driven. Here, but they are given it is only entropy driven, so therefore it is false. So statement 2, 3, and 4 are true. So what you have to do is like you have to add 2 plus 3 plus 4. So the answer is going to be
9.
okay. So this is how like you have to do the answer. Yes. It's just solubility of AgCl in 0.1 CaCl2 is x is to 10 power minus 2. Then value of x is Ksp of AgCl is given. So we know that CaCl2, right? So CaCl2 is a strong electrolyte. So it will give you like Ca2 plus 2Cl minus N. The initial concentration is 0.1. So here you'll be getting like 2 into 0.1. Complete distribution of it because it is strong strong electrolyte. Okay, so the concentration of Cl minus is going to be 0.2. So from this we have done with the concentration of Cl minus. Now moving with AgCl, AgCl will only, it is partial, right? It will not completely dissociate. It is partially soluble. So here it will give you Ag plus, which is in solid, and Cl minus. Okay, Cl minus. So now Ksp is equal to concentration of Ag plus into concentration of Cl minus. It is aqueous. Both are aqueous. Cl minus are aqueous. But here it is not, why we are not writing at the bottom. If we write also, the concentration of AgCl of the solid is remaining going to be the minus 3. So now Ksp is given as 1.8 into 10 power minus 10 is equal to concentration of Ag plus is solubility. So I can write this as like S into Cl minus concentration is 0.2. So now what you have to find out is S alone. So S will be equal to
9 to 10 power minus 10.
9 into 10 power. Yes. So what will be value of x? X is going to be 10 power
9.
minus 10. It is given already. So x alone. So therefore it is going to be. You have this question?
Yes, ma'am.
Moving with the next question. RC triple bond CH. When you treat with diborane tetrahydrofuran H2O2 NaOH, you'll be getting A. And in presence of CRT, you get the product, which is the major product. For the major product, you have to do like how many isomeric products can be obtained. R is equal to ET in the given reaction. So here, first you do with the common reaction. And when R is equal to ET, how many isomeric products you will be getting is the question. Yes. So when I take like an alkyne, treat it with 1 and 2, that is diborane H2O2 NaOH. It what would be A will be what would be what you're going to do over here. It is like B2H6 H2O2 NaOH. Here hydration takes place in presence of diborane and peroxide. Okay, hydration takes place. That is, you are going to add water in the triple bond, that it follow Markovnikov's rule or anti-Markovnikov's rule. B2H6 H2O2 NaOH. When peroxide is present, what it will follow? Markovnikov's rule or anti-Markovnikov's rule?
Anti-Marconi.
It will follow the anti-Markovnikov. Okay. So here we are adding water, H2O2. So H2O2 is peroxide, and in presence of like NaOH, OH minus ion will take up the hydrogen, and here diborane is given. Yes. So therefore, your product will be like, you'll be adding H2O like this. So you'll be getting RCH2CH2 as the product. So which is your aldehyde A. And this on with Cl2. Cl2. So one equivalent only. Okay, one equivalent Cl2 in presence of H plus. So what happens here? Substitution takes place to form R CHCl CH. Okay. So now if this R is equal to ET, how many isomeric products will be getting? For the number of isomeric products will be getting. Can I say that this is a chiral carbon?
Yes, ma'am.
It is a chiral carbon. Okay, so I can get its mirror image. So one will be like plus, the other one will be minus. So answer is going to be like, you'll be getting yes, this question. And next question. How many of the value of crystal field stabilizing energy with strong field as well as the weak field? Ignore pairing effect. Pairing effect. What is the how many of the following ions in octahedral complex have equal value of crystal field stabilizing energy with strong field as well as weak field? Is the question. So for this, what we have to do is you have to calculate the CFS. You have to do with the CFS. Yes. So it is going to be like D5. It is D6. Is Fe2 pluses, D6, Fe3 pluses, D5, and chromium 2 plus. Chromium 2 plus is going to be D4, and cobalt 3 plus. Cobalt 3 plus is D6. So how many of the following ions in octahedral complex have equal value of crystal field stabilizing energy with strong field as well as with weak field? So you have to like evaluate strong field ligand, what will be the CFSE. For weak field ligand, what will be the CFSE? Yes, you have to evaluate. So here it will be like T2G 5 EG0. Yes, here it is like T2G6. Here it is T2G6. Here it is T2G5, T2G4, T2G. The pairing takes place, right? And for weak ligand, it will be T2G3 EG2. T2G3 EG2. Here it will be T2G3 EG2. So T2G4 EG2. T2G4 EG2. For D5, it will be T2G3 EG2. And for D4, it is T2G3 EG1. Again, it is T2G4 EG2. Now, the CFSE for both the strong field and weak field are going to be same. Are going to be see, none of the configuration is same, right? None of the configuration is same over here. So is the CFSE going to remain same for the both for the strong field and weak field, ignoring the parameters? Is it going to be same? No, right? If you do the CFSE calculation for T2G5 and T2G3 EG2, it is not going to be same. Yes. So, okay, for example, we'll do for T2G5 and T2G calculation. Write the formula and do the calculation. So what is the formula of minus 6 into number of electrons in T2G. So what is the number of electrons? Minus 0.4. Minus 0.4. The number of electrons. So number of electrons in T2G is going to be like 5. Yes, so this and minus 0.6 into minus 0.4 into 3 plus 0.6 into 2 is not going to be same. It is not going to be same. Yes. So therefore, none of the one will have the same CFSE energy for both. Okay. So the answer is going to be 0. Okay. Got this question? Like if I have the same configuration for both, then I can get the same CFSE energy. Okay. Ignoring the pairing energy. So therefore, it is not going to be the thing over here. Okay. Got this question?
Yes.
Okay, so moving to this would be the last question. So the following graph is plotted for as of what would be the value of n? So you have to find out like for which orbital you get. So what is the number of nodes over here? And nodes. Yes, you have 2 nodes. Radial n minus. For s orbital, what is L value for s orbital?
0.
0. So what will be N value? So for 3s orbital, you'll be getting this probability delta. Yes. So therefore, n value. So here the answer will. Okay. Yes. This
Yes, ma'am.
Okay, so I'll meet you tomorrow. And for tomorrow, the topic is, check the topic once. So you will revise for tomorrow's class. Okay, haloalkenes and haloarenes. So go through haloalkenes and haloarenes. So tomorrow we'll discuss the question on it. Okay, so thank you for now. You can leave the session now. Thank you. Thank you, everyone.